Today I'll be showing you a triangle drawn with IA32 assembly. The goal of this assignment was to draw an isosceles triangle with a row number specified by the user. I'll be taking you through my program piece by piece to give you a better understanding of the thought processes and techniques I used. The most advanced tools used here are subroutines and jumps, so let's get started. The very first thing I declare in my assembly programs are my system calls and file descriptors. Anything that I can do to make my program a little more human readable, I will definitely do it. Next, I define what constitutes my triangle, which are the constants for a star and a space. The starting row, space, and star positions are also defined, and these are extremely important for determining if a space is printed, a star is printed, or it's time to end that particular line of the triangle. A new line variable is declared here as well. In my BSS section, I have reserved a byte of memory for the number of rows to be input from the user, as well as a temp to store the number of rows at one point. You will see that shortly. You could also push that information to a stack, but in this case, I went with a temp variable. So the first three blocks of the section.text are the opening message, getting the user input stored in num rows, and then printing that user input for the user to see. Down here, one part of assembly which I consider to be tricky is maintaining consistency with which the format of the numbers interact with each other. There are keywords we can use to negate having to worry about this, but here I'm going to do so just manually to emphasize the importance of keeping the formats of the numbers consistent. The very first thing I did after this was subtract a 0 character from the user input. Without doing so, the input would be in ASCII format, and this makes it difficult to do arithmetic with other hard-coded values. So here is the first loop of the program called print row. It represents the outermost portion, and inside will be various calls and jumps to other blocks, but everything stems from here. Each time this label is encountered, we are either about to start printing a new row or checking to see if we are done printing the triangle completely. This entire chunk is representative of the contents of this for loop, and the blocks below represent the nested for loops. So sometimes it's hard to understand what is happening at the start of a loop, including right here. I mean, this is pretty self-explanatory. We're just returning to the very next line to start printing the potential next row of the triangle. However, these two move statements seem a bit trivial, but rest assured they aren't. They're actually used to reset the positions of the space and the star variables. Without doing so, the positions of the spaces and the stars for a triangle would be all over the place, and our triangle wouldn't be a triangle. So after these two reset instructions, we move the value of the current row, which starts at 1, into the AL register. We then compare this value to the value of the total number of rows via the CMP instruction, and depending on the result of that instruction, we will either continue printing or we'll exit the program. So in the previous slide, there was a conditional jump to this label, and the program will jump here if and only if the triangle is not done printing. This block contains two calls, one for printing the spaces and then one for printing the stars. And it also contains an increment instruction for increasing the row number. And finally, there is the jump to the print row label, which is checking to see if it needs to keep printing. So let's move on to the space print block. The first thing you'll notice here is that is what seems to be two labels, which is true. However, the top label signifies a label from a jump, while the bottom one represents a label for a procedure. Even though this code loops properly by jumping to the procedure label, semantically, I believe it's better to keep jump labels and procedure labels separate. Moving on, you can now see the reason why I created a temporary variable. This temp is used to store the total number of rows, and it's important that we use a temp so that the original number of row variable isn't altered with any arithmetic. You could alternatively store the number of rows into a register, push that register onto the segment stack, and then pop it back out for later. However, for the purpose of sticking to procedures and jumps, I used a temp variable instead. So we subtract the current row number from the total number of rows. This difference is necessary for determining the amount of spaces for a given row. That difference is then moved back to the temp variable and then compared to the current position of the next space. If the space position is less than this calculated difference, we know we have to print more spaces and therefore jump to the actual print statement, which is right here, print SB. Once this condition is no longer true, we'll return to where this procedure, print spaces, was called, but until then, we'll continue printing spaces. So here, after the space has been printed, we must increase the space position by 1, which is this increment instruction. Finally, we jump up to the label directly above the procedure name. Going back to what I said about being semantically sound, this is a jump to a label instead of to the procedure call. So by the time this loop returns to where it was originally called from, to where print spaces which was originally called from, which is right here, we'll have printed all of the spaces for one row of the triangle. Now we're in the right position to print stars for that row. So let's do that. So this snippet has a similar format to the prior block with a jump label right above the procedure name. So below that, we are calculating the length of the triangle on a given row, which gives us the number of stars we're going to need for that row. Similar to the format of the previous block, we will continue printing stars until the position of the next star is greater than the calculated row length. Once it exceeds the row length, we will go back to where this call was made. But until then, we'll keep printing stars. By the time the loop returns to the call, we will have printed a full row with both spaces and stars. And since we've already coded the greater for loop for the overall structure of the triangle, this was pretty much our last major snippet. And finally, just here's the new line block, which we use a couple times earlier. And here is the system exit, and here is the output for 9 rows. I will just quickly run it so you can see that it does what it's supposed to. I'll put 3 there. And as you can see, there's 3 rows. Let's do 8. And there's 8 rows. So hopefully, through procedures and jumps, you can see that a lot is possible. Not even digging into that deep of advanced topics. So a lot is possible. Anything that is possible with higher level languages is definitely possible with assembly. So